Question 15a. A block is attached to a spring, oscillates with negligible friction on a horizontal surface. The spring constant and the block mass are 40 Newton per meter and 0.3 kilogram respectively. At the instant shown, the spring is 0.1 meter longer than its unstretched length, and the block is moving to the right at 2 meters per second. What is the block spring system maximum potential energy during a complete oscillation cycle? So here we have a spring mass system which has a spring constant K of 40 Newton per meter, and the mass of the block is 0.30 kilogram. The spring is stretched by a distance of x equals 0.10 meter, and it is moving with a speed of 2 meter per second to the right, and we need to find its maximum potential energy. Now you can find maximum potential energy if you know the maximum displacement of the spring, which is its amplitude, but we do not know its amplitude, we just know how much it is stretched at the given instant. So we can find the total energy of the spring at that instant. We can write total mechanical energy A to be sum of kinetic energy plus potential energy at the given point. Now when the spring's potential energy becomes maximum, its kinetic energy at that instant becomes zero. So we get the total energy to be equal to the maximum potential energy of the spring, which is also true for maximum kinetic energy. So total energy of the spring at any given instant is always constant because the law of conservation of mechanical energy. And this value of total energy will be equal to either the maximum potential energy or the maximum kinetic energy at any given point. So I can write the maximum potential energy to be just the sum of kinetic energy plus potential energy at any given instant. So we find this as kinetic energy at this given point is half mv squared. Potential energy will be half kx squared. So we write U max to be equal to half mass of the block is 0.3, velocity is 2 squared plus half spring constant is 40, displacement is 0.1 meter, so 0.1 squared. That gives you the maximum potential energy to be equal to 0.80 joule. Then in the next question, 15b, we have a similar case where we have a spring mass system where the spring constant is 15 Newton per meter and the mass of the block is 0.2 kilogram. At the instant shown, the spring is 0.1 meter longer than its unstretched length, and the block is moving to the right at 1 meter per second. What is the block spring system maximum potential energy? So again, we write the spring constant K to be 50 Newton per meter. Its stretched distance is 0.1 meter. Mass of the block is 0.20 kilogram. And speed of the block at that instant is 1 meter per second to the right. We need to find the maximum potential energy. Again, we can say that maximum potential energy will be equal to total energy of the spring at that instant. Total energy you can find by adding kinetic energy and potential energy at that point. So this becomes equal to half mv squared plus half kx squared. So which is equal to half. Mass of the block is 0.2. Speed is 1 squared plus half. Spring constant is 50. X is 0.1 squared. And when you solve this, you get the maximum potential energy of the spring to be equal to 0.35 joule.